More sequences. Okay. So we need to understand what's going on here. A1 equals 4. That means that the first term has a value of 4. AR plus 1 equals AR plus 3. AR plus 1 is the next term. So whatever term you're on, AR plus 1 is the one after in the sequence. So what it's saying is the next term will equal the previous term plus 3. So if the first term is 4, the next term will be the previous term plus 3, 7. The next term will be the previous term plus 3, 10, and 13. So those are our first 4 terms. Pretty easy. Find the sum of the first 100 terms of the sequence. Right, I'll go through the sum to n terms of an arithmetic as well. With an arithmetic, you have an initial value, and then your next value will be that value plus some amount. And then the next value will be that value plus the same amount again. So it'll be a plus d plus another d. D stands for difference. So this third one will be a plus 2d, and it's pretty obvious to see that if for the first one you had no d, the second one you had 1d, the third one you had 2d. For the nth one you will add n minus 1d. Now, the clever bit is if we take that sequence and write it out backwards. So a plus n minus 1d at the end, a plus n minus 2d, a plus n minus 3d. This is what it would look like if we kept the ones off. And then the last one obviously be a, and before that will be 2a plus, and well, why am I writing 2a? Sorry. Should really go to sleep now. A plus d. Okay, now what this means is if we take those SNs and add them together, we get 2 SNs are equal to, well, the clever bit here is that each of these pairs, this pair, this pair, this pair, this pair, and so on, add up to the same amount. So if we've got a and a plus n minus 1d, that makes 2a plus n minus 1d. And if we've got a plus a, that's another 2a, plus n minus 2d plus another d, or n minus 2d plus another d is n minus 1d. So each of these occurrences, obviously these are the same, will all add to 2a plus n minus 1d, which means that you've got 2a plus n minus 1d happening 1, 2, 3, 4, 5, n times. Yeah, there's n lots of these pairs. So if that's what two lots of the sum to n terms add up to, then it's not a major leap to see that the sum to n terms is going to be half of that. Now, that's the formula we need to use here, so I'll just delete all the justification. If it'll actually disappear, it seems to be refusing. Something to do with layers, presumably. So if we want the sum to 100 terms, then we're going to use this formula here. Now, the key elements of the formula, we need to know what n is. In this case, it's the sum to the first 100 terms, so n is 100. We need to know what a is. Write down the first bit, it's 4. There's going to be n minus 1 there, which is going to be 99. Don't know why I'm writing in 99. And d is the difference between the terms, which is 3. So I'm sure I could have explained that better, but anyway, essentially we've got 100 over 2 plus 2 times 4 plus 99 times 3. And if we plug all that together, and there's our answer. Very nice.